Hello everybody. Next we're going to take a look at a Pemdas problem with fractions. This problem can be divided into a fraction subtraction problem and another fraction subtraction problem. And then after that we have to do what's in the parentheses first, starting with the parentheses on the left, then with the ones on the right. Then we will divide the answers we get for each of these two. We'll divide those answers by each other. So this can be considered, we've got two fraction subtraction problems and then one division problem. So let's take a look at this on the tablet. We have 7/9 minus 7/45 divided by 1/15 minus 2/75. Okay, so what we have to do is find, because this involves subtraction within the parentheses, subtraction or addition always involve finding similarities between the terms we want to add or subtract. So with fractions, we need to find common denominators. We have to have the denominators be the same before we can subtract them. So that's one extra step we have to do. So if we have, if you guys are up on your multiplication table, you'll see that 9 goes into 45 evenly. So if we can turn this denominator, 9, into 45, then we can save some time and just convert one fraction to do the subtraction. So let's go ahead and try that. I think 9 times 5 is 45. And if we multiply the denominator by 5, we also have to multiply the numerator by 5. So, and if we multiply both numerator and denominator by the same number, we will create an equivalent fraction which is the same, it's equivalent to 7/9, but it's got a different value. So 7 times 5 is 35, 9 times 5 is 45, and now we have 35/45 minus 7/45, and that's pretty easy to do. 35 minus 7, this top number tells us how many pieces there are. There's 35, and we're removing 7. And then the bottom number tells us what size they are. So this is like the units, and the units are the same. This is similar to decimal math, where the units are in the columns, and so the columns have to be lined up. With fractions, it's one step more difficult because we have to create denominators that are the same. We have to make them the same units. But right now we're just taking 35 of these units and taking away 7. That leaves 28 units, and the unit size is 45. So 28/45. So now we're going to divide that by 1/15 minus 2/75. Okay, let's get a different color. And not everyone will see this, but as you do more and more work with math, you can probably see these are both divisible by 5 because they both end in 5, 15 and 75. We need to find a denominator that will work for both, and it's easiest if one of these divides evenly into the other, and as luck would have it, we have that in this case. 15 goes into 75 5 times, so really similar to what we just did. We're going to multiply the numerator and denominator by 5 and create a new equivalent fraction. So 5 times 1 is 5, and 5 times 15 is 75, and we're subtracting 2/75. So you'll notice this with WAMAP. When you do future problems, like on the test, you may end up having the same number used to make equivalent fractions. Anyway, remember how to make them, and then every once in a while they will cut you some slack and make it a little easier to get to the answer. So anyway, we have 5 of this unit, and we're taking away 2 of that same unit. So that leaves 3 of that unit, which is 75. So now we can rewrite our problem as 28/45 divided by 3/75. Okay, so normally what we do when we divide is we do the keep, change, flip method. So let's use blue. So keep means 28 divided by 45 is the same. Change means change the sign, and I suggest writing an asterisk this way for multiplication. And then we flip this 3/75 to 75/3. Okay, and then we just multiply these together. So one thing we can do is we can produce the fraction That means pre-reduce. This is a little term I made up to reduce. We're going to reduce these before we multiply. So with this problem, we're going to be dividing by 45 and multiplying by 75, so we can use them to cancel each other out. If we can find the biggest number that goes into both of those evenly, which I think is 15, we can divide. We can take a 15 out of 45, leaving 3, and a 15 out of 75, leaving 5. And then we could reduce any of the bottom numbers by any of the top numbers, but I think that's as far as we can go. So here we're going to multiply 28 by 5. And do you remember my handy-dandy multiplication by 5 shortcut? Take half of the number that isn't 5, which in this case would be 14, and then add a 0. So 140. So if you want to write that out the longhand way, you can do that. 5 times 28. 5 times 20 is 100. And 5 times 8 is 40. 100 plus 40 is 140. And then on the other side, for the denominators, we have 3 times 3. And that's going to be 9. Okay. And we can look at these. 140 is an even number. Let's take a look at the factors of 140. There's 2 and 5 and 10. And what else goes in there? Oh, 7, right? 7. Put 7 in here. And then 7 times 10. So that means 5 times, 28 we had. 28 goes into it evenly. And then 2 times 70. And then I think that's about all. And 9, we just have 3. 3 squared. So 3 is our only factor, no common factors, so we cannot reduce this fraction. What we're going to do is divide. I'm going to do this over here so it'll all fit on one screen. 140 divided by 9. And we'll take this improper fraction and turn it into a mixed number up here. 9 goes into 14 once. 1 times 9 is 9, leaving 5. And 9 goes into 50 5 times, which is 45, leaving 5. So from that we get a fraction, mixed number, 15 whole times. So we have 15 whole parts and then 5 pieces left over. That's the remainder. And the size of each piece was 9. So 15 and 5/9 is the mixed number answer, and 149 is the improper fraction number. Sometimes at WAMAP they say don't change it. Sometimes they say do change it. So this would be our answer. Okay, 149 or 15 and 5/9. All right. So why don't you give that a try? If you get stuck, send up a flare. Send me a message from inside WAMAP. I'm here to help. All right.